Okay, this is graphing polynomial functions. I'm on page 4 of the Unit 2 packet. We've got some steps here for sketching the graph of a polynomial function. I'm going to go through each of the steps and do a couple of examples. And the first thing we're asked to do here is to determine the degree of the function. The way I determine the degree is by looking first to see what type of or how my equation is written. Is my equation written in factored form or in standard form? Number 1 down here is written in factored form. How do I know that? Because it's got parentheses in it. So it's written as basically a list of factors. So if it has parentheses in it, then it's written in factored form. If there are no parentheses, it's in standard form. Okay, so factored form has parentheses. Okay, so this one is in factored form. Now I need to determine the degree. Since it's in factored form, it tells me the way I'm going to figure that out is by adding up all the powers of x. So let's add up all the powers of x. There's 2. There's another 2, so that makes 4 total. This is 1, so that would be 5. And this one's 3, so that gives me a total of 8. When I add up all of those exponents, I get a total of 8. Therefore, gotta love that, my degree is 8. Okay, this is done. Next, determine if the function is positive or negative. The way I know if it's positive or negative is by looking in the front of the equation right here. Is there a negative sign there? No, there's no negative sign. Therefore, this function is positive. Positive. Okay, so it is an even function. Since the degree is 8 and 8's an even number, I have an even function and I have a positive function, even and positive. What I do with that is I go back in my notes to page 1 and I look at the chart. Now you will have to know this chart on assessment day. So figure out a way that you can remember this chart. But even and positive means I'll have up, end behavior. So let's go back to my graph and record what I've figured out, that my end behavior is going to be up. Okay, that's really important for my graph. So let's check these steps again. I did this, determine the end behavior. I did that. It's up. Sketch the arrows on the graph. So that's just a little helpful thing for me when it gets to be time for me to draw the actual curve. If I have these already there, then I know where I need to begin and end when I get ready to draw my graph. Okay, next on the list of things to do is to list the roots as well as the multiplicity. That means the behavior at each root. Remember this, the behavior at each root is either a cross or a bounce or a wiggle. Each root is going to do one of those 3 things. So I need to know how to determine cross, bounce, or wiggle. And first I need to list all the roots. Okay, the way I list the roots is by looking at the factors. So one at a time, we'll look at each individual factor. This one here, x minus 2 means I have a root at positive 2. We flip the sign, okay? If I have a factor that is x plus 4, that means I have a root at negative 4. Okay, if I have a root, or excuse me, a factor that's x minus 5, that means my root is going to be at positive 5. And then I purposely skipped over the one here at the beginning, which is this x squared that's out here in front. It's not inside of parentheses. If an x is out there by itself, not inside of parentheses, that will always mean you have a root at 0. So that one has a root at 0. Okay, now as far as the cross, bounce, or wiggle decision, that comes from the exponents. At 0, the exponent is 2. The exponent is 2. So I refer to my notes on page 3. If I have a power of 2 or any other even number, I'm going to have a bounce. So that means on this graph at 0, it's going to bounce. So underneath 0 right here, I'm going to write bounce. Okay, next at 2, here's the root. It doesn't matter what the root is actually, it's the exponent that matters. This is its multiplicity. The exponent is 2 here. And we know an exponent of 2 or any even number will bounce. Okay, go to the next one. This next root, the exponent is 1. According to my notes on page 3, a power of 1 is going to cross. And then my last factor has an exponent of 3. And on my notes up here, an exponent of 3 or any odd number that's bigger than that is going to wiggle. It's only an exponent of 1 that will cross. That's the only, but then the other exponents, odd and even, give us bounces and wiggles. Okay, so we have now listed all the roots and the behavior at each root. Next, we need to plot the roots and then sketch the behavior at each root. So I'm going to plot all 4 of these roots, meaning I need a big circle on each spot, at positive 2. I need a big circle that I've colored in to indicate that's a root. At negative 4, make a big circle and color it in. At positive 5, make a big circle and color it in. Okay, so now I need to draw in their draw in their multiplicity, or draw their behavior at the root. And those are fancy ways of saying the cross or bounce or wiggle. All right, you're going to have to begin at either the far left or the far right. So let's start over here. Since I know that it has to be pointing up at the end of this graph, negative 4 is going to cross. So I'm going to, let me clean this up a little bit, make it a little bit neater, and just cross. Okay, now that I know the direction of that, I can go to 0, and 0 is going to bounce. Since 0 has to bounce, it has to come from this direction, so it has to bounce underneath the x-axis. So you can only get each next point, each continuous point. I'm trying to figure consecutive. That's what it was. Each consecutive point you can draw after you know the behavior of the previous point. So it has to curve naturally. There's no sharp points or edges to any of these graphs. The next root is at 2. 2 is a bounce again. So 2 is going to be a bounce, and it has to be continuous from the last root. So we're going to do something like that. And then at 5, it needs to wiggle. So knowing I have to end up going going up in the positive direction, that means this is going to have to wiggle through this point sort of this way. Okay, there we go. All done. I've connected all parts of my graph after I plotted all my roots. There's my cute little lumpy, curvy polynomial function. Okay, so I'm going to go through one more problem before the end of this video. My suggestion would be for you to pause the video, fill in all of the key features here and draw the graph, and then go back and play the video in order to check what you have. That would be my suggestion. So if I were you, I would suggest that you pause now, do this on your own, and then come back and check. Okay, degree. To get the degree, I add all the powers of x. 5, 6, 7, 8, 9. My degree is 9. Okay, 9 is an odd number. So I have an odd function here. 9 is odd. There's not a negative sign in the front. So right here tells me it's going to be positive. So I have an odd positive function. Odd and positive. That means my end behavior is going to be up on the left, down on the right. So I'm going to go ahead and do this over by my graph, so I'll have that information when I'm ready. Next, I'm going to list the roots. So let's go one at a time. This tells me I have a root at -2. And -2, there's an exponent of 5. An exponent of 5 means I have a wiggle. Okay, next. That factor there means I have a root at +2. The exponent 2 tells me I'm going to bounce. Okay. And x plus 5 is the factor. So -5 is the root. The exponent is 2, so at -5, we're going to bounce. Let's go over to the graph and plot each of these points. So when you plot the points, there needs to be a big circle that's colored in at each of the roots. So it's very obvious where those roots are located. Okay, I'm going to start over here on the far left. I'm going to start at -5, and -5 is a bounce. So since I have to be pointing up over here, I'm going to be bouncing on top of the x-axis. So it's going to be something like this. So -2 is the next point I come to, and it's a wiggle. Since I've bounced up here, to get around here to this wiggle, I'm going to have to do something like this. And then my last root is a bounce on +2. So here you can see as I continue my curve, I'm underneath the x-axis. I have to be pointing down here. So I'm going to take the curve and bounce like this. So that way my end behavior is correct and the behavior at each root flows and curves in all the right places. All right, there we go. There's plenty more for you to practice on, and the answer key is posted on Canvas. So lots and lots of practice.